Hey, hi guys. Can you please confirm I'm audible? Just let me know once in the chat, yes or no.
Yes, sir. Sorry,
Yes,
sir.
sir, audible.
Okay, okay, no issue. Fine. So let me share my screen and then we can continue. Fine. I hope my screen is visible to you all, right?
Yes, sir.
Yes, sir.
Okay, fine. So today we will start with the GPT model. Okay, so this is again like one of the famous, I can say famous LLM model that we have. Okay, famous LLM model, and based upon this particular model, again that we have the multiple variants, even multiple times that we have used in our projects as well. That is called OpenAI GPT 3.0, GPT 3.0 version, right? So let's start with GPT. So what I can do, let me write it down here. That is called okay. Fine. So GPT. Okay, so here we will understand each and everything from the research paper to the reality, like how and what are the things that we have in our research paper, and based upon those particular research paper, how that we are using in our day-to-day life, we can say how that we are using in a reality. Okay, so first let's try to understand the basics building blocks. So GPT stands for Generative Pre-trained Transformer. Generative Pre-trained Transformer. Everywhere in all the LLM and in all the NLP SOTA model, that you will get the name that is called transformer, because the base that we have here is a transformer model. Okay, so the GPT here stands for Generative Pre-trained Transformer. Okay, now let's try to understand the meaning of each word here. So the first word that we have, that is called generative. Generative, it means it can create the new content. Okay, so generative, it means it can create the new content based upon the guidance. Pre-trained, it means it learns from the general knowledge. Okay, so it learns from the general knowledge. It means whatever the data that we are going to use to train this particular GPT model. So definitely that we can use the different data, like we can use the books data. Okay, we can use the Wikipedia data, we can use the research paper, we can use the complete GitHub data. Okay, and many other sources that we can use to train this particular GPT model. Okay, the researchers, they have used the different data set to train this particular model. So generative, it means it can create the new content. Pre-trained, it means it can learn a general knowledge first. Okay, and the transformer, it means this is the internal architecture that we have that help us the model to understand the context. Okay, so it helps the model to understand the context. Okay, so this is the meaning that we have for generative pre-trained transformer. Generative, it means create the new content. Pre-trained, it means it learns everything from the general knowledge. Transformer, it means it will help us to understand the context of the data. Now let's try to understand how the GPT actually works. Okay, how the complete GPT model works in a real time. Okay, so think like a super advanced autocomplete system. Okay, just think like a, okay, let me write it down the point first of all here. So how GPT actually works. Okay, So think like a super advanced autocomplete system. When you start typing, let's say if I talk about the WhatsApp, okay. So when we start typing something in our WhatsApp, it next data, predict the next data based upon the things that we are going to type. Okay. It means that we are getting the autocomplete option, autocomplete word that we are getting. So based upon our previous context, let's say that I'm going to write something called, let's say I need to send one message like I love apple. Okay. Now, whenever I type I, okay, so after that, whenever I write ill, I will get some suggestion like, love. Okay. Now, again, whenever I write O, so again that I will get some suggestion. Again, whenever I write V, we will get some types of the suggestion. Okay. So what happened in this particular GPT application, it works as a auto complete system. So when we start typing, it predicts what comes next based on the everything that we have learned, or based upon the things that we have typed in our mobile phone. Okay. So in this way, the complete GPT model works. So based upon the training data, or based upon the learning, our GPT model, it will help us to predict the next word based upon the context, whatever the context that we have used to train the model. Same thing happens in the WhatsApp. Whenever we write the some data, some words that we are getting the some character, I can say, whenever we write the some character in our WhatsApp, we are getting the complete words. Okay. So this is the autocomplete system. It helps us to generate the autocomplete data. Okay. Now the GPT models are based upon the transformer architecture, especially decoder person. Okay. So in a bot, we have learned bot is a bidirectional model, and bot is a only encoder model that we have. Encoder model. Encoder model. Now in a GPT, this is the decoder model only. Decoder model only. Bot is a encoder model. GPT is a decoder model only. If I show you, let me open my Chrome. Now here if I search encoder model only, and if I show you on the images, so I will get some segregation here. So let me check. Yes. So as you can see here, we have some models. So let me open in the new tab. Yeah. So as you can see, here we have the complete transformer. So in a transformer, as we know, we have the encoder, we have the decoder. So in left hand side, we have our all the encoder based model, only encoder based model. In a right hand side, we have our all the decoder based model. So as you can see in the decoder based model that we have GPT, we have GPT-2, we have GPT-3, we have a GPT Neo, GPT-J, and CTRL. These are the model that we have only decoder model. Now, if I talk about the encoder model, so we have the bot, we have Distilbot, Robota, XLM, XLMR, Albot, Electra, Distilbot, Debota. So these are the some of the encoder based model that we have. Now, if I talk about both encoder plus decoder, so here we have T5. This is the encoder plus decoder model that we have. BART. This is the encoder plus decoder model. M2M100 decoder plus encoder model. Big BART. This is the encoder plus decoder model that we have. So these are the some of the segregation that we have. Some model only works as a decoder. It means it can generate the output. It can generate the output. Now here encoder, it means in a encoder what happened? We have only one thing that is called like MLM, mask language model. We will discuss in some time. Okay. In a decoder, we can say it help us to generate the output. Generate the output. Okay. So the GPT model are based upon the transformer architecture, especially decoder model only, especially decoder portion only. Okay. Now, this architecture is designed for auto-regressive task where the model predicts the next tokens in a sequences. Okay, so the GPT model, mainly I can say this is the auto-regressive model that we have, and mainly this particular GPT model that we use to predict the next tokens in a sequences. So let's say we have one sequence of the data, and from those particular sequence of the data, if I need to predict some types of the word, okay, so those particular word GPT help us to predict. Okay, so this is the decoder based model that we have only. Now, as we know, GPT stands for generative pre-trained transformer. So generative pre-trained transformer. So this is a type of AI model developed by the developed by the Open AI. Okay, so this particular GPT model, OpenAI companies, they have developed this particular entire model, and this particular GPT model, it understand each and everything, I can say, based upon the deep learning. Okay, so it explore the complete deep learning concepts, understand each and everything, whatever the data that be used to train the model, and based upon those particular understanding and the I can say the contextual understanding. So based upon those particular contextual understanding, then it generate the text like a human, text like a human. Okay, because whenever we saw the chat GPT, so in the backend, the researchers, OpenAI companies, they have used the complete GPT model, GPT-3 model. And based upon those particular model, they have created the complete chat GPT platform, where the whenever the user asks any types of the query, that we are getting the answers as a human generated text, as a human generated text. Okay, so what happened, this particular GPT model, it help us to generate the text like a human, text like a human. Now let's try to understand the concepts behind the GPT. Okay, let's understand the complete concepts behind the GPT. Okay, so as we know, in a like transformer architecture, we have the two important point. Okay, so in a transformer, that we have the complete neural network that we can see. So let me write here, like concepts behind the GPT. Concepts behind GPT. Okay, so in the GPT concept, the first point that we have, that is called transformer architecture. Transformer architecture. Okay, so as we know, transformer architecture like a neural network architecture, and it designed to handle the sequential data like text, Okay, now in a transformer, that we have some important concepts, as we all know. First one, that is called self attention. First point, that is called self attention. So what happened in self attention, it focus on the different parts of input sequences when making the prediction, so we can say self attention mechanism. This is the first point that we have. Second point that we have, that is called position encoding. Position encoding. So what happened in position encoding, it add the positional information to the input tokens in a transformer to not process the data sequentially like the RNN. So what happened in RNN? We directly send the data in a sequence manner, and then our RNN, it generates the output, but not. The same thing we can't do in a transformer. What we do? First, that whatever the data that we have, we convert this particular data into the vector, where the vector size that we have, that is called 512. And after that, we assign the position to each vector, and then we send to those particular data to the self attention mechanism, where our self attention mechanism, it focus on the different parts of the input sequences whenever it making the prediction. Okay, so this is the second point that we have, and the third one that we have, that is called feed forward layer. Feed forward layer. Now what happened in feed forward layer? It is a fully connected layer that transform the data, or I can say the information, attended information. Okay, so it transform the complete data in a I can say the complete information in a normalized format. Okay, so these three important point that we have in a transformer. Now after that, second point that we have, that is called pre-training and fine tuning. Pre-training and fine tuning. Till here, guys, can you please confirm anyone, any doubt? Yes,
Clear,
no,
sir.
Clear, sir.
all clear?
Clear, sir.
Now next point that we have, that is called pre-training and fine-tuning. Okay, pre-training and fine-tuning. So GPT follow actually two steps. First one is a pre-training and the second one is a fine-tuning. Okay. Now what happened in pre-training? What happened in pre-training? The pre-training, the model is trained on the, I can say, huge amounts of the data, as we know, like the complete transformer or the bot or any other NLP or the NLP SOTA model or the LLM model. Those models are already trained on millions and billions of the data using unsupervised learning. Why the unsupervised learning? Because whenever we are getting a data from the Wikipedia or from the books or from the GitHub or from the research paper or from the other sources, those data are not labeled. So whenever we have the labeled data, then we can say supervised learning. But whenever we have the unlabeled data, we can say unsupervised learning. So the GPT models are already trained on millions and billions of the data. Then after, based upon those particular training, the pre-training part, it helps us to predict the next word in a sequences based upon the existing training, I can say. Existing training, it helps us to predict the next word in a sequences. This is called a pre-training, where the researchers, they have already trained the data on millions and the billions of the data. We just need to call this particular GPT model and then we can use it. Now second thing that we have, that is called fine tuning. So in a fine tuning, as we know, the pre-trained model is already trained on the lots of data. So what we can do in fine tuning, that we have the specific task. Okay, we have the specific task or we have the specific data set. So what we can do, we use those particular data set to fine tune the existing model. And based upon this particular data set, whatever the data set that we have received, first of all, that we can fine tune, and after that we can enhance the performance for the particular application, whatever the application that we are developing. So one major differences that we have in a pre-training and fine tuning. So let's say if we are using the pre-training method. Okay, so in a pre-training method, let's say that we are getting the 73% of the accuracy for the particular task where we are working on, I can say, like any types of the, like next sentence prediction project. Okay, NSP project that we are using, that is called next sentence, I can say the next word prediction. Next word prediction. Okay, so NWP. So let's say that we are working on this particular application and we are using the pre-train. Okay, now what happened? Our client say no, like we are getting the 73% of the accuracy. So what you can do, we have one data set. So use this particular data set and fine tune the existing model. So what we do in fine tuning, we change some parameter value or some other value that we can add or we can remove based upon our existing requirement. And after that, whatever the data set that we have received from our client, we use this particular data set and this particular modification, and based upon this one, then we fine tune this particular existing model so that we can enhance the performance for the particular task, as well as we can get the higher accuracy as compared to the previous one, that is called pre-training part. Okay, so this is the major differences that we have in pre-training and the fine tuning. In pre-training, we just use the model. In fine tuning, based upon the specific data set or the task, that we do the modification in the model and then we can fine tune. Clear this particular second point, guys? Yes, no?
Yes, sir. Clear, sir.
Yes.
Yes,
Now,
sir.
Yes, sir.
try
Yeah.
to understand the learning process for the fine tuning and pre-training. Learning process for the fine tuning and pre-training. So here, next point that I'm going to write, that is called the learning process. Okay. Now in a learning process, the first point that we have, or I can say the step number one, that is called again pre-training. Okay. So what happened in pre-training? Model reads each and everything, whatever the data that we have used. So the researchers, they have used the billions of the data from the Google, where they have selected the books dataset, Wikipedia dataset, GitHub dataset, research paper dataset, and the so on other things. And based upon those particular things, they have trained the complete pre-trained model. So what happened in pre-trained model? It learns the pattern in a language by trying to predict the what next word will comes whenever we are going to write something in our WhatsApp, or whatever the next word prediction that we are going to do. Okay, so it learns the pattern from the existing data, whatever the existing data that we are going to use for the training purpose. And based upon this particular learning, it helps us to do the final prediction for the particular word. Now, if I give you one example, so here we have one example. So example, like let's say we have one sentences that is called the cat the cat sat on the, and this is the next word that we need to do the prediction. So what happened? It learns our GPT model. It learns everything from the data itself, whatever the data that we are going to pass, that is called this particular data. And based upon this particular data, it will give you the prediction. Okay, so the cat sat on the mat or chair or chair or chair. So based upon the, I can say, the general understanding of the language, then it will help you out to predict the next word that is called mat or chair. Okay. So as a human that we can easily say, okay, so the cat sat on the mat, mat. But this is difficult for the models like GPT. Okay, it's a difficult to do a prediction like a GPT. Okay, so that's why first of all that we use the billions of the data, and again researchers, they have used the billions of the data to train this particular model. And that's why based upon the previous language understanding, whenever we use the GPT model, it will help you out to do the prediction. Okay, now after that, second point that we have, that is called fine tuning. Okay, so the goal in a fine tuning to do the prediction based upon our data set. So based upon our data set, it means what we can do, whatever the task that we are going to perform, let's say like in any particular task, next word prediction. So based upon those particular task and the word, what we can do, we can fine tune our existing model so that we can achieve the, I can say, good performance along with the good accuracy. So last time, let's say in a pre-training that we are getting 73% of the accuracy. So after parameter changing and the data set training, we can expect let's say 85 or the 90% of the accuracy. 90% of the accuracy, plus it enhance the performance during the prediction as well. Okay, so these are the actually benefit that we are getting whenever we are using the pre-training and the fine tuning part. Okay, now if I talk about how the GPT works, okay, how the GPT works, so that we can follow here the same bot approach, little bit changes that we can do here. So how GPT works. Okay, so first thing first, that we can do the tokenization here, whatever the data that we have. So first that we need to do the tokenization. So the text is, I can say, broken down into the smaller units, okay, or I can say words or the subwords. This is called a tokenization. So first thing, whenever we will get the data, we need to do the tokenization. After that, the second step that we have to convert the tokens into the vector, that is called embedding. So second step that we need to do the embedding for the existing token. Third thing that we can apply the self attention so that our model learns the relationship between the words and the sequences. So here we can say the attention self attention mechanism. Okay, and the fourth point that we have, that is called decoder only architecture. Now if I show you the architecture once again, so let me open it once. Yes, so let me open the research paper that is called attention all you need, and even GPT research paper. Let me show you the research paper as well. So in a like in a decoder, as you can see what happened, I mentioned the first is a tokenization, second is a embedding, third that is called self attention, and the fourth that is called decoder. So GPT use only the decoder stack from the original transformer architecture to optimize a text generation types of the application. To optimize the text generation types of the application. So if I open the research paper, yes. So from this part, this is the transformer architecture that we have. If I show you here, so from here, decoder use only right hand side architecture. Bot use only left hand side architecture. Okay, bot use only left hand side. GPT use only right hand side architecture. If I show you in the official research paper, so this is the official research paper that we have, that is called generative pre-trained transformer. Definitely, I will get something here as well. So actually here we are not having the like entire, yeah, so as you can see, this is the transformer architecture that we have. Transformer architecture that is called encoder, and this is the decoder layer that we have right hand side. Okay, now here you can see the researcher, they are using only the decoder model. So transformer architecture and input transformer for the fine tuning on the different tasks. So here they are doing the complete fine tuning on the different tasks. Now if I show you here as well, so here you can see again the same thing that we have in this particular images as well. So first of all, what we do? First of all, that we convert the data into the tokens. Then we can do the embedding. Then after that, we can apply the self attention where we calculate the scores to get the relationship between the word and the sequences. And after that, we can apply the decoder architecture only from the our original transformer architecture, so that it can optimize a next generation types of the application. Okay, so this is the actually architecture that we have. Okay, going forward, even I will show you some other things as well. Okay, but right now the researcher, they have used only the right hand side part. Okay, now after that, in this way, the complete GPT works. So tokenization, embedding, self-attention, and the decoder architecture only. Okay. So yes, guys, let me know till here if you have any doubt. Yes, no.
No, sir, no doubt.
No,
Okay, fine. See, at the end, now we just need to understand this particular part. So we all know what is this one right hand side and the left hand side. Okay. Now I'm going to show you the different types of the variants, like GPT variants, I can say, and what are the modifications researchers they have done in this particular original architecture to build a GPT. Apart from this one, most of the part, I can say 70-80% of the same architecture that we have, only 10-20% of the things the researcher they have changed. Nothing else. Okay, so now let's talk about the variants of GPT. So here I'm going to write GPT variants and evolution. Evolution. Okay. So first, let's start with the first one that is called GPT-1. Let me take some water. Just give me a second. Okay, fine. So first, let's try to understand the GPT-1. Okay, so the GPT-1, the OpenAI company organization, they have released in released in 2018. Okay. Now here in GPT-1 parameter size that we have parameter size 117 million. Let me confirm once. I'm little confused. Let me check. GPT parameter. GPT-1 parameter, I can say. GPT-1 parameter size. It's approx like 100 like 17 billion, but let's verify. Yeah, so as you can see here, 117 billion parameter that we have in GPT-1. Okay. So yes, these are the parameter that we have. Guys, can you please confirm in bot base how many parameter that we have? Yes, bot base and bot large. How many parameter that we have in bot base? Jaya, Ravi Teja, Purnima, please confirm. In last session, again in last to last session, I already mentioned many times. How many parameters that we have, guys, here in bot base?
110.
3, sir.
10.
110 million. What about the bot large?
340.
340 million parameter. How many stack that we have here in bot base? 12 stack. Here, 24 stack of the layer that we have. Right, remember these try to remember these points actually, okay, because in a most of the time interviewer they directly ask, okay, so how many parameter that we have in bot base or the bot large. Okay, so it will help you out actually for the long term as well whenever you work on the any research project or for any organization where you are going to do the comparison between different model. Just now I shown you like the different types of the models, right? So here as you can see, like these are the model that we have. So sometime what happened, let's say, let me open my epic pen once. So let's say that you are working on one of the application like text summarization or the question answering system, and first that you started with bot model. Let's say that you started with the bot model. Now what happened, bot model, let's say if it took like 1 minute for one prediction, 1 minute for one prediction. Now your team lead or the client say, okay, no, I need some other model. So here that we have the other models options, right? Robota, Distilbot, XLM, XLMR, Allbot, Electra, Debata, T5. So these are the models that you need to experiment. Now, how that you can experiment, how that you can think, okay, so we need to go ahead with this one, or this one based upon the parameter size. Because right now here we have only 20-30 models. But in real time, if I talk about the total NLP models, so we have approx, I can say, total LLM models, okay, total LLM model, I can say 70 plus model that we have. And we are not having much time to do the implementation with each and every model. No. So how that you can do the comparison and how that you can select the model based upon the parameter size. Based upon the parameter size. So that's why we remember those particular, some of, I can say, some of the important parameter for the GPT and the bot, Distilbot, Robota. Okay, so those parameters that you need to remember, it will help you out for the longer time as well. Okay, so here in GPT-1 that we have like it released in 2018, and after that here the, I can say, the parameter size that we have, that is called 117 million parameter. Okay, now if I talk about the limitation and the key contribution, okay, limitation and the key contribution. So the GPT model that we can fine tune on any task, whatever the task that we are going to develop. So based upon our task that we can fine tune this particular model. Why? Because here we have the less parameter, only 117 parameter that we have. 117 parameter size that we have here. So we can fine tune on any specific problem statement, whatever the problem statement that we are going to work on. Okay. And the second point that we have, that is called limitation. So here limited size capability that we have. Okay, limited size capability. So whenever we have the smaller data set, we can use this particular GPT-1 model to develop our application whenever we have the small, I can say the limited data. Limited data. Let's say we have the 5,000, 10,000, okay, or I can say 50,000 data. In this case, that we can go ahead with the GPT-1 model, that we can get the good accuracy and the good performance as well. Okay, so these are the some of the points that we have in GPT-1. Now let's talk about the GPT-2 model. Okay, GPT-2 model. So this particular GPT-2 model released in 2019. Released in 2019. Here we have the parameter size. Parameter size that is called 1.5 billion. I can say this is the larger version that we have actually. Larger version. Okay. Now, if I talk about the improvement as compared to the older version, that is called GPT-1. So in a GPT-2 that we have the little bit improvement, I can say. So first of all, this particular GPT model trains on the larger data set. Here as you can see, the researchers, they have used only 1.5 billion. Here we have the like 1.5 billion that we have here, and here we have the only 117 million. So just think about the parameter size and the data the researchers they have used to improve this GPT-2 model. Okay, first thing, GPT-2 model, it trains on the, I can say, huge and the larger amounts of the data. Second point that we have, GPT-2 model is capable of generating any types of the contextual relevant text. Contextual relevant text, I can say, like it will help you out to generate any types of the blog, any types of the post, LinkedIn, Instagram, Facebook, or any types of the emails or any other things whenever we need, like whatever the task that we are developing where we need to generate the text. Okay, so this particular GPT-2 model, it will help you out, and it is capable of generating a contextual related text, or we can say the contextual relevant text. Okay, so these are the some of the improvement that we have in GPT-2 model. Now we have some features as well. So first features that we have here, the strong performance without any specific data. Okay, so what we do in a GPT-1, I mentioned that we can fine tune this particular model based upon the specific data set and the task. Based upon the specific data set and the task. In GPT-2, without without fine tuning, that we can achieve the good performance and the good accuracy for the particular application. Okay, now apart from this one, this GPT-2, it can generate the text that could, I can say, the mimic the human writing style. So let's say if you need any types of the text in I can say in simple English or the professional English. Okay, so even we can generate those types of the data with the help of GPT-2 model. Okay, but yeah, we have one issue as well. Okay, we have one issue as well with the help of GPT-2. That's why the researcher, they come up with the next version that is called GPT-3. So let's talk about the issues here. So only one issue that we have. So sometime what happened, this GPT-2 model, it generate the fake news actually. Fake news. Okay, so that's why this is the one of the concern the researchers, the OpenAI organization, they saw, and then they come up with the new model that is called GPT-3. Because of this particular issue, they come up with a new model that is called GPT-3. Next model. Okay, so this particular GPT-3 model, till now everyone clear? Can you please confirm once? Yes.
Yes.
No. Yes.
Yes, sir.
Yes, sir.
So GPT-3 model, because of this particular issue, the researcher think, okay, so let's work on the next model that is called GPT-3. Okay, so this particular model, it released in 2020 actually, 2020. Okay, here that we have the parameter size that is called 175 billion parameter. 175 billion parameter. Again, here we have some key improvement I can say. Okay, so this GPT-3 model improved the language understanding and generation capability actually as compared to the previous one, that is called GPT-2 and GPT-3. Okay, apart from this one, in GPT-3 we have the features like few shot, one shot, zero shot learning, so that it can enable these learnings like few shot, one shot and zero shot learning through the prompt, so that without fine tuning we can generate the output whatever the actual output that we need. Okay, so I hope you remember, we already know like in prompt engineering I already mentioned like we have the topic that is called few shot learning, one shot learning, zero shot learning, and the COT that is called chain of thought. What we do here, we provide the prompts to the model, and then model it help us to generate the output based upon the prompt, whatever the prompt that we are going to pass. Now based upon the GPT-3 that we have the one famous model or the application that I can say that is called chat gpt.com, chatgpt.com, where we just write a prompt, no need to fine tune, no need to do a fine tuning, no need to use the data set to fine tuning on our specific task. We can just pass the prompt, and based upon the prompt that we can expect the final output, whatever the output that we need. Apart from this one, whatever the modification that we need of our output, we can change our prompt and then we can get the final output. Okay, so these are the some of the key improvement that we have. First improvement, it understand the complete, I can say the language understanding plus a generation capabilities. The researchers they have enhanced in GPT-3 model. Second, with the help of prompt, no need to do the fine tuning, no need to use our data set, we can improve the complete performance and the whatever the output that we need. Okay, so these are the some of the variants that we have, that is called GPT-1, GPT-2 and the GPT-3. These are the famous variants that we have. Apart from this one, we have the Neo as well actually. But right now we are not having any research paper or the any resources to understand this particular GPT Neo model. Okay, because the researchers they have not published anything till now. Okay, so going forward, in if in future it will come, definitely that we can read and then we can understand. Okay, now we have some application here in GPT-3. So first application that we can develop like chatbot. Next that we have that is called writing assistant, like LinkedIn writing, Facebook, Instagram. Code generation. Fourth that is called I can say the creative writing, creative writing. Okay, so these types of the actually these types of the application that we can develop with the help of GPT-3 model. But again, now we have some limitations here in GPT-3. First limitation, it's too incentive, too I can say too expensive to train and deploy the model. GPT-3. Okay, it's a too expensive to train and deploy the model. First thing. Second thing, second limitation that we have, it may produce the bias or incorrect output sometime based upon the training data. So let's say if I talk about the recent things. Okay, let's say if I talk about some news related to the cricket. Okay, what the things are happening nowadays in IPL match. Okay, so in this case, we can't get the correct output actually. Okay, so if I show you, so let me open my chat GPT. Okay, so let me here, I'm just going to write. Okay, so tell me about the mega auction 2025 IPL. Let's see if I will get something. Okay, so it's searching from the web actually. Okay, so look like that I'm using the paid version. Let me see. Once again, let me check my plan once again, like which ID that I'm using here. No, like, okay, so it's searching from the web actually. Okay, so look like that I'm using the paid version. Let me see. 1 second, let me check my plan once again, like which ID that I'm using here. No, like, 1 second, let me check my plan once again, like which ID that I'm using here. No, like, 1 second, let me check my plan once again, like which ID that I'm using here. Let me check the account here. Okay, so actually I'm using the paid account. That's why here you can see that we are getting the complete output. Okay, but yeah, it happens in our, like, I can say in like GPT-3 model. Okay, in a GPT-3 model. So as this particular model is trained on the previous data set. Okay, so that's why it might be possible sometime it produce the bias or the incorrect output due to the training data set. Okay, due to the training data bias data set, I can say. Okay, so these are the some of the limitation that we have in GPT-3. Now after that, we have the next model that is called GPT-4 as well, and then we have the GPT Neo actually. So next model that we have that is called GPT-4. Now in GPT-4, so this particular model released in 2020, it's a 2023, yes, 2023. Okay, now here parameter size, we are not having any idea for the parameter size, but some sources say, because the, like, the OpenAI companies, OpenAI organization, they have not released anything related to a GPT-4. Okay, that's why we can't say any parameter right now, but some sources, okay, some news channel, they say okay, so the here OpenAI organization, they have used the trillions of parameter to train this particular GPT-4 model. Now just think, if we have the trillions of data set, trillions of parameter, okay, so just think how much capabilities that we have in GPT-4 model. Okay, so till now we are actually not having any exact number, but as for the source, we can say trillions of the parameter that we have. Now here we have some key features as well. So GPT-4, it enhanced the reasoning and the contextual understanding. First, second, it improves the handling of the complex queries and the complex topics. Third thing, it has the multimodal capabilities actually. It can understand and the generate text based upon the images as well. And even I'm using this particular GPT-4 model in the real time, where like we are playing with the images and all. In a real time, I can say the production for product I already delivered in my organization. Okay. Now, apart from this one, we have some application, like we can develop the application like healthcare, education, content generation. So these are the some of the applications that we can develop. Okay. So these are the some of the variants that we have for GPT, guys. Now let me know if you have any doubt in all the variants GPT 1, 2, 3, and 4. Anyone?
No, sir, no doubt.
All clear?
Yes, sir.
Okay, fine. Now, if I talk about the one more things in a GPT variant, so first thing in chat GPT, use the reinforcement learning actually. RLHF, one of the concept that we have in generative AI, reinforcement learning with human feedback. So based upon the human feedback, chat GPT, it will give you the response. So let's say if you are going to write something, and next time if you say, no, this is wrong, okay, so this is like ABC or XYZ is my expected output. So based upon your feedback, a chat GPT, it will learn and then it will give you the final responses. So we can say chat GPT use the RLHF concepts, that is called reinforcement learning with human feedback, to make the responses. Okay, to make the final responses. Okay, now apart from this one, we have the other models as well. As I mentioned, we have the GPT Neo. We have the next model that is called GPT Neo. We have the next model that is called GPT-J. Actually, it's a GPT-J. Huh? GPT-J. And apart from this one, we have some other models as well. Okay, so these are the recent research that we have in a GPT, in a OpenAI organization like GPT Neo and the GPT-J. Now they are working on actually AGI. AGI. Okay, so artificial general intelligence, they are developing some application. Okay, so AGI types of the application they are working. Okay, now let's try to understand the GPT architecture. Most important point in GPT architecture. So first, some of the things that we have the same thing. Okay, little bit changes that we have in a GPT architecture. Okay, based upon the decoder. Okay, so first point that we have here, that is called first point that we have, that is called, okay, so first point that we have, that is called tokenization. So here we can convert the text into the small I can say the tokens. Okay, so we can convert the complete sequence of the data in a small text. But here we can use one famous technique. The researchers, they have used the famous technique that is called byte pair encoding. Byte pair encoding, that is called BPE. Okay, so this is the one of the technique the researchers they have used right now. Like if I talk about the NLP, so we have learned the different technique like word tokenization, sentence tokenization, and some other techniques. Right now, the researchers they have used here the byte pair encoding technique to convert the sentences into the tokens. To convert the sentences into the tokens. So this is the first step that we have. Second step here that we have, that is called input embedding. Input embedding. So each token that we can map with the high dimensional embedding vector using the one technique that is called lookup table. Lookup table. So again, the researchers they have used this particular technique to convert the data into the embedding vector. Now after that, third technique that we have, third point that we have, that is called positional encoding. Positional encoding. In a positional encoding, we do the same thing. So transformer process the token in a, I can say the parallel data. Okay, so what we do, whatever the tokens that we have converted into the embedding, this particular embedding, that we assign the position for each word. Okay, so this is called the positional embedding. Same thing that we do, we just change the tokenization by like BP, byte pair encoding. In an input embedding, the researchers they have used the lookup table. Now after that, after these three things, the fourth point that we have, that is called decoder stack. So again, a decoder only stack that we can say the backbone that we have for the GPT. So here that we have the 12 layer for the GPT small, but you can say GPT small, that we have GPT-2, I can say here GPT-2 that we have the 12 layer, and for the GPT-4 we have the 96 layer, actually 96 layer. So just see the differences. In GPT-2 we have the 12 layer only, GPT-4 that we have the 96 layer. Okay, now again in a decoder layer, if I show you, so in a decoder layer, what we do, we have the multi-head self attention, mask multi-head attention, and the multi-head self attention. So here fourth point that we can say here the, no, in a third point A I can create here. So in a third A that we can create the multi-head self attention. What we do here, we use the self attention to compute the relationship between our data to understand the complete contextual understanding, that we use the self attention. After that, first point I can say here, the self attention that we use to understand a contextual understanding for the language. So self attention. Second point that we use, where we calculate the queries, we calculate the keys, and we calculate the value, and based upon this one we calculate the score, right? After that we apply the scale dot product attention. So third point we can say scale dot product attention, where we apply the softmax, and in a softmax that we can say query into key divided by 8 into value. Same thing that we do to calculate the attention, that is called score. Can I get yes or no? This is the calculation that we do, guys, to calculate the score.
Yes.
If I show you the research paper again, so here you can see this is the same softmax that we have, positional embedding. Then we have the self attention, and in a self attention Okay, it's a difficult little bit to showcase here, so it will be good that I can open the JLMAR blog transformer. I can say transformer. And if I show you here, same thing that we calculate softmax q into k. So query into key divided by 8 into value. After that, we are getting the Z score. Same thing that we have here. So scale dot product that we calculate, right? After that, whatever the score that we are getting, Z1, Z2, Z3 that we calculate. And after that, we can send to the next point that is called feed forward neural network. We send those particular data to the feed forward neural network. After that, we have the residual connection and the layer normalization. As usual, whatever the things that we have in our research paper, in our official research paper, same thing that we do here as well. Little bit modification that we have, whatever the modification I mentioned. Okay. Now after that, we apply the auto regressive modeling. Okay. So fifth point that we have, where we apply the auto I can say regressive modeling. Okay, so GPT is trained based upon the auto regressive. It means it generates the next tokens based upon the previous tokens or based upon the previous word, whatever the word that we are going to pass. And at the end, what we have the output layer where we use the softmax to get the probabilities, and based upon those particular probabilities that we are getting the final output. Okay, so these are the complete things that we have in our GPT. Now let me show you my doc file. So this is the doc file that I created. Let me show you one by one the complete doc file here. So here basics building block, starting from here that we know, okay, how this is works. So based upon the transformer architecture, we have the transformer architecture, key concepts behind the GPT, pre-training and the fine-tuning, how the learning process works, like pre-training and the fine-tuning. After that, different variants. So GPT released in 2018, 117 million parameter. Key contribution and limitations that we have. For GPT-2, released in 19, 1.5 billion parameter that we have, largest version. GPT-3, 175 billion parameter. And GPT-4, where we have the estimated to have the trillions parameter as for the sources, whatever the source, like news source that we have. Okay, now here we have the different GPT variants like Instruct GPT, Chat GPT, Codex GPT for the code only, GPT Neo, GPT J, and some other models. We have the architecture. First is a tokenization. As I said, we are using here the byte pair encoding to convert the sentences into the tokens. Input embedding, where we use the lookup table to convert the data into the embedding vectors. Okay, now after that, positional encoding. So whatever the vector that be converted, now we can assign the positions. Decoder sticks, where we calculate the multi-attention using the first self-attention, query key and value, we calculate. Feed forward network data. So whatever the score that we are getting, we can send to the feed forward neural network. Then residual correction and the normalization to normalize our data. After that, we have the auto-regressive. So GPT is trained on the auto-regressive dataset. Mask self-attention is used to ensure the model only consider preceding tokens. Next one, I can say the preceding tokens only. After that, we have the output layers. Okay. So the final output of the decoder stick is a vector of each token, which is passed through the softmax layer to produce the probability of the next token. As I said, probabilities that we are going to calculate. After the probabilities, then the model select the tokens with the highest probability, or the sampling technique like top K or the nucleus sampling can be used to generate the text. Here we have the some visualization code. So embedding, positional embedding, self-attention, feed-forward neural network, decoder, and the softmax function that we are using to do the probability. So in this process, one by one, embedding, first input data, embedding, positions, multi-attention, feed-forward neural network, decoder, and then softmax to calculate the probability. Here we have some base how that we can enhance the GPT variance. So GPT-2 architecture. So increase the model depth with the parameter, support up to 48 layers, and the embedding size that we can increase to 1600 plus dimensions. Okay, we can use the byte pair encoding for the efficient, because this is the one of the best encoding technique that we have, tokenization technique that we have till now in a NLP or in a generative AI field. Okay, byte pair encoding. In most of the generative AI model or the LLM model or the NLP model, you saw the same technique. The researchers, they have used same types of the technique. Now in a GPT, 175 billion parameter for serializing, that we have the GPT-2, introducing adaptive embedding layer for the better memory utilization, and so on. We have some enhancement here that I have mentioned. Now here we have the transformer innovation behind the GPT. So first is a self-attention, scalability, layer stacking, pre-training, and the fine-tuning diagram. Okay, and that's it. So yes, guys, this is all about the GPT. Okay, so these are the different variants that we have. Okay, so mostly for the fine-tuning, we use the GPT-1 and GPT-2 only. Okay, because in a GPT-3, we just need to pass the prompt, and based upon the prompt, that we can generate the final output. Okay, so mostly that we use GPT-1 for the fine-tuning task. Okay, so yes, this is all about the GPT and its variants, guys. Let me know if you have any doubt, anyone, in GPT and its variants.
No,
All
sir,
clear?
no doubts. Yes, sir,
Okay,
clear.
fine. So yeah, this is all about the today's session. One thing, so may I know the update for the assignments? Yes, Jaya, Ravi Teja. Okay, Jaya for the is fine. What about Ravi Teja, ma'am?
Yes, sir, I'm doing.
I didn't finish, sir. I will
I
do.
did not get you, Ravi Teja. Please come once again.
Yes, sir, I'm building the project.
Okay, so till when I can expect the final output?
Tomorrow I will show you, sir, definitely.
Okay, fine. Yeah, so tomorrow we have the session, guys. Okay, because Wednesday, like the same time, I have the multiple session. Okay, in not a session, actually, it's like client meeting. Okay, so tomorrow that we can cover the next model, that is called Llama and Llama 2. Two model that we can understand tomorrow. Okay.
Okay, sir.
So yes, this is all about the today's session. Ravi Teja, please try to finish the assignments. Okay, if you want, you can take the help from my YouTube channel as well. I already uploaded the videos. So go through the
Yes.
video and try to add the features, whatever the features that I've mentioned. Okay,
Okay.
and don't just copy and paste the code. Okay, so just watch the video, and based upon those videos, try to add the features, whatever the features that I've mentioned. Okay. Okay, fine, guys. So yes, this is all about the today's session. Tomorrow we can understand the next model, that is called Llama and Llama 2. Okay, guys, clear?
Okay, okay, sir.
Okay, and shall we connect tomorrow 7 p.m. Jaya, if this is fine for you? 7
Yes,
to
sir.
8.
Okay, sir.
Okay, so yeah, let's connect tomorrow 7 to 8 p.m.
Okay, sir.
Okay, and then we can learn the next model. Okay, now I'm sharing the doc file. Just go through the doc file. Okay, if you face any issue, you guys can reach out to me directly. Okay. Okay, fine, guys. So let's conclude here and see you tomorrow. Okay. Yeah. Okay, guys. Thank you. Yeah.